And we are live.
Welcome back to the useR conference. My name is Marcela Alfaro Cordova, and I am an assistant professor at the University of Costa Rica. I am here to introduce Noam Ross, but first we would like to thank our studio for their sponsorship to useR 2020. About our speaker today, Noam Ross is Principal Scientist for Computational Research at the nonprofit organization EcoHealth Alliance, where he researches wildlife disease dynamics and the emergence of new zoonotic pathogens and develops disease forecasting tools. Noam is also on the leadership board of the rOpenSci project, where he is a funding editor for software peer review. He contributes to a variety of projects in R and reproducibility, including the Rocker project, and R packages such as Fasterize and Redoc. Noam holds a PhD in ecology from UC Davis. So without further ado, please help me welcome Noam Ross.
Thank you very much, Marcella. And thanks to the organizers, the conference sponsors, our studio, and everyone who's managed to pull together what's becoming a great virtual event on the fly. Today, I'm going to be talking about the peer review projects at rOpenSci. This is a project and organization that I've been working with for 7 or 8 years now, and has really been a joy to be part of, especially all of the people who have been involved with the peer reviewing process, ranging from authors to reviewers to editors and all of the different contributors. But let me start out with a little bit about what rOpenSci is. So we sometimes call rOpenSci a developer collective. It is a community of people working on R and reproducibility that has porous borders. We like to say we build technical and community infrastructure to support open reproducible science in R. So we like to say we build software and we build communities. And that takes many different forms, involves many different roles, but it means we need a lot of different people. So we have this developer community with very loose edges. There are 12 leadership and staff at rOpenSci, but that's just the tip of an iceberg of a very large group of people that involves the people who are part of our discussions in our forums and our chat who provide mutual support, the many co-authors on our blog, the many people who contribute packages and code. And what we're really happy about is how many people we have contributing code to the R packages that we develop, the many people submitting code to us and reviewing that code, and how many of those people are new users. We had over 100 new contributors in the past year in terms of who are their first people contributing code to an rOpenSci project or an rOpenSci package. And it's that sort of constant community input that makes everything we do work. That group participation, that community spirit is what allows us to make our impact. We want to make sure that we help develop tools that accelerate science and make science more impactful, that help researchers in their work and help software developers and research engineers get credit for that work so they can fully participate in the scientific and the academic process. And so we develop many packages. Many of those go through the peer review process. And an important thing to us is that we can see that work out in the world. And so we try to track the citations and the impacts and the uses of the work that our co-authors and contributors are able to provide. And over 120 of the packages that we've published, we've seen cited in the scientific literature over 800 times. And that's just what we've seen. We all know that it's often difficult to track that kind of thing, and that's something I'm going to be talking a little bit more about. But we think that impact is really deep and really wide, and it's something we're very happy about. But the core of rOpenSci's work is really in package development and facilitating that and developing it ourselves. rOpenSci develops a lot of different packages that are primarily across what we think of as the scientific data management lifecycle. So these include things that connect to databases, that connect to scientific repositories, that help researchers manage project metadata, process things that come out of scientific instrumentation, including strange formats, getting things uploaded and connected and processed so the whole data management lifecycle can be reproducible. That's really been our bread and butter. That's what rOpenSci has worked on from the start. And at the early stages, that is what our core staff worked on developing. And that was most of what rOpenSci did. But very quickly, we started getting contributions from many other researchers and package developers out in the scientific world, providing packages to our ecosystem. And we realized that we needed some sort of management quality control process to vet those packages and help bring them up to a level of quality that we were able to support and distribute. And over time, that process, which has become our peer review, has become a core goal of what rOpenSci does in and of itself. So rOpenSci's peer review process is a hybrid of things that we've drawn from in the software engineering world, which is where some of our staff and some of our core comes from, and the academic peer review from the scientific research world, where many of our community come from as well. And both have something to contribute to a process by which we are reviewing our packages. So code review in a software engineering production environment is often very granular. It often comes in the form of, say, looking at a pull request. A single pull request goes into a project. It'll have a narrow scope. Usually you're working on a project, you send in a pull request, you're looking for a few specific things about compatibility and project style, and making sure that these few lines of code hopefully are doing the right thing. It's done amongst project collaborators, people who work together, people who know each other, people who have a common set of standards and ideas and goals. And usually the main goal of it is quality control. You want to make sure that the product you're putting out is consistent, that the software that you're developing is bug-free and meets the standards that you have set out for yourselves. There are a lot of contrasts between that and the academic peer review process, which typically occurs on scientific manuscripts. That review project is usually not on one tiny little bit, but project-wide. A group will publish a paper. The paper describes everything that they've done, often over a period of years, their methods, their results, their outputs, their inferences and interpretations. And all of that is up for grab. The reviewers really are able to look at all of it and make a combination of comments and sometimes demands for changes that is really a wide-ranging review over anything involved in the outputs. And those are not usually your collaborators. It's peers in one's field. That's where the peer review part comes from. And it's other experts who are able to bring in outside expertise and alternative viewpoints. And that's one of the great advantages of the academic peer review model. And the model there is to help improve quality of the work, certainly, but it also has a component of conferring legitimacy. Often things like journals are not just where you review, but they are some sort of gatekeepers. They are markers of quality. They are ways to distribute your work so that it has the stamp of approval of others. So we combine aspects of both of these in the rOpenSci peer review process. So for instance, we do work on whole R packages. We do things that are project wide and broad in scope, because it's not an iterative process where one little bit is submitted and another little bit is submitted, but people are submitting a whole piece of work to be reviewed and to get a stamp. On the other hand, we don't work anonymously. The fluid sort of nature of the rOpenSci community means that reviewers can become collaborators and vice versa. Lots of collaborations emerge from the review process and that matching process. So people are not necessarily anonymous. And what we do is we hope that our common standards and our common guidelines bring a degree of common view on what the level of quality should be. And together, we think that we'll be able to provide some quality control to projects that are peer reviewed, and also help others that are out in the field understand that quality and see the legitimacy of an rOpenSci badge of approval. But while that's been helpful for our packages to have that stamp of approval, and people really appreciate that, we've found that peer review is a great mechanism for a lot of different things that are our goals at rOpenSci in working with this scientific software development community. First off, we're really interested in driving adoption of best practices and standards. Many of our community members are not programmers or software engineers by training by any stretch of the imagination. I'm not, much of our leadership is not. Probably less than a third of our members and participants are not, actually are. And so we want to be able to bring software engineering principles of robustness and testing and good maintenance to a community of people who are doing this part-time and don't necessarily have that background, but are working at it as part of their research in biomedical science or the social sciences or history or epidemiology or any number of different fields. We want to bring best practices to them. We find peer review is a good way of doing it. Another important thing is that we find we're able to bring an increase in quality in the long tail of applications. There are a lot of applications and packages out there that are very popular and get a lot of eyes on them through sort of the open source bug reporting pull request process, but the long tail of applications is different. There are a lot of important, if not widely used packages that need eyes on them. And then the process itself brings people together to build a community of practice. And that's really one of the biggest things that we do, is build that community and bring people together along those lines. So let me talk a little bit about each of these. First, driving the adoption of best practices and standards. It turns out that the peer review process is really a great tool as a teaching process. And it's a teaching process both for package authors who submit packages and reviewers and editors who view the code and bring packages along in the process, because there's a great diversity of types of code that's submitted that reviewers can then have an opportunity to see and learn new things. And then people who submit code learn lessons from the reviewers, and that back and forth exchange that we have between reviewers and authors that they can bring back to their next project. This is one of the big pieces of feedback we get from our author and reviewer community. We occasionally survey that community to understand what we're doing right, what we're doing wrong, how we've improved in the past year, what sort of features and projects people are interested in. And this is some of the most consistent feedback. People who are reviewers will learn something, learn a trick, learn a new package, learn a different tool that they can use to bring back to their own work. And people who are authors have learned a new way to structure their packages, a better set of dependencies, a better way to organize their code from their reviewers. And that's something that's a ratchet that brings a little more knowledge into the community each time and brings a little more consistency into the way people develop scientific code. Then there's this project of, really pushing down the long tail of scientific applications and programs. This is, it's a little bit an old graph. I think the order of magnitude might have changed, but the pattern certainly has not, of the distribution of monthly downloads of packages. So on the left, all the way, we have our RCPPs and our dplyrs and our tidyverses, and the packages that thousands or tens of thousands of people are using on a regular basis. They're finding bugs, they're putting eyes on the code, they're submitting PRs. There are big communities built around those packages. And peer review isn't necessarily where they're getting the most value, because they're going to get a lot of people bringing feedback. But most packages are not like that. And irrespective of sort of the importance of the work, there might be much smaller communities. So if you write a package that's for a specific type of analysis or accessing a specific type of data, there may only be a few hundred practitioners who actually use that package on a regular basis, which means that only a small fraction of those might be the type of practitioners who have the knowledge or the initiative to get in touch with you about bugs, or to provide feedback, or to participate in the development process to improve those tools. So a peer review process is something that helps bring that external view to more packages. I like to think of this example. It's from a number of years ago. It's called DB Hydro, and it's an rOpenSci package that provides access to the South Florida Water Management District's database. There's not a lot of people out watching this talk, I'm sure, who are doing work that means they need to access this database or manage this particular hydrological data. But that database is what's used to make plans and decisions about how the Florida Everglades are managed. And it's how both researchers and regulators at Florida State Departments are making decisions about flow through the Everglades and managing wildlife in the face of climate change. And so it has a lot of important decisions being made based on it for a lot of people. And I think it's important that data be managed well, that the analysis that's done of it isn't sort of subject to programming errors. And so if only a few hundred people are downloading it a month, and most of those are actually bots, but it's a few dozen, I think it's really good that it goes through a peer review process. It's part of that long tail. Another example of long tail type packages until very recently are a number of ones in epidemiology. These are not ones we've reviewed. There's an organization we've worked with closely much in the past, and maybe someone is speaking about it at useR this week, called the rEpidemics Consortium, that runs a similar review process and a curation process for packages for analyzing epidemiological data. Many of you, if you've looked at a coronavirus data dashboard of a state agency of your country, of something a university has put up, very likely are looking at something that has run through these packages, which have a very small community of practice using, but have an outsized impact. And so it's this long tail that we're really interested in figuring out how to bring more quality and support to. And then finally, building a community of practice is core of what we do. Like I said, a lot of people who are our membership are actually, full-time researchers, regulators in agencies, in universities, in governments, in nonprofits or private industry. They're building these packages on the side. Often they are not embedded within a large team of programmers or data scientists. And so we need to be able to connect them with each other and make those networks of expertise work for each other. So one of the best things about the peer review process is the development of those ties. It's really been explicit in the design of the process. It's why we sort of make the trade-off of not making an anonymous process, because we see those connections happen, those communities build, new projects emerge when people are able to have these open conversations. Our peer review process is managed entirely through GitHub threads. So a package will be submitted, it'll be placed in the GitHub thread, and the reviewers and the authors and the editors will have an ongoing conversation rather than sort of a one-time exchange of letters. And that enables people to learn from each other and learn about each other. And when there's the type of response that's best given as a patch or a pull request, we do that rather than something written. And it's really, we've seen projects emerge out of this, and it's something that we're really happy is part of the core community. Now, this is actually kind of surprising to me in some ways. Many of you probably have been involved in the sort of academic publishing process at one stage or another. I think it's a very important thing. Peer review is a very important thing for the type of work that many of us do, sort of a foundation of sort of the scientific process. But I can't say I ever look forward to getting the reviews of a paper I submit. And when I give this talk before a live audience, I ask people to raise their hands about this. It generally, that comes with a deep feeling of dread. That is something that I know I have to deal with, but is something that is not so, I'm not so happy about. And so it's been kind of a shocking thing to see how much people like the peer review process. We've endeavored really hard to make it friendly and to make it not about gatekeeping, but about improving people's work. And people enjoy it. People comment that they like the community. They're looking forward to the feedback, which is always surprising. And that's sort of the best response that we can get. And it's something that we're very happy about. So we've learned a few things in the course of developing this peer review process. The first one is that we need to document everything. We have the standards that we've developed for packages, the peer review processes we've developed, guidance and examples and all sorts of things for the authors and the reviewers and the editors, and the guide for the editor and the guide for the editor-in-chief to manage the other editors. And these are all things we learn along the way, and writing it down and iterating on it is incredibly important. So what we've turned from what became a short README file in the original repository into a book. rOpenSci packages, development, maintenance, and peer review. Mel Salmon, who's been on our editorial team for a long time, is the main keeper of the development guide, as we call it, which you can find at this link. And all the links together that I'll be showing here, there'll be a lot of URLs. They're all in the repository that I'll have a link to at the end of the presentation. But we manage our standards and processes like a piece of software itself. We have regular releases. We have news files of updates to standards, updates to recommendations for what dependencies or packages should use, updates to the best example of how to respond as a reviewer to something you find in a package, updates to the process of how people work through. It's a constant evolving thing. And the most important thing we found is to write it down. And so writing down how we do it is really important for any process by which you are trying to develop a common workflow, a common set of standards by which people are going to evaluate each other's work. The next thing we find is that you really have to build a review process around what users really care about. There's a lot of opinions and a lot of sort of abstract and theoretical and formal reasons why people prefer different code styles, different code architecture, different function names, different things along those lines. There's a lot of different ideas, and there are a lot of sort of rabbit holes one can go down in establishing, code should, look like or run like, X or Y or Z. But we find you can't really build a review process around sort of those abstractions, because both authors and reviewers aren't going to focus on that. So you have to build the review process around what users of packages really want. And we find, the top thing for that is documentation. People have to be able to understand how something works. And so the first thing we ask reviewers to review is the documentation, because documentation is the biggest thing, and then usability, and then performance, and then features. And so while the code review does go into looking at code line by line and looking at correctness, the focus of users and reviewers and authors really should be the things that people are dealing with every day, which is the paths to entry of the software. Of course, the biggest path of entry is installation. We see a lot of cases where someone brings something and it turns out it's not going to work on one system, to work on someone's setup, not work. Our ecosystem is actually very good about making sure that things work well and install everywhere. The CRAN really makes that a core feature. It's easy to get binaries for your operating system generally, but a lot of times people need to bind to external software, people need to wrap things, people need to connect to online services through their software. And that's the first bump in the road for people, and working that out so that users are able to do that is the first thing that our editors and reviewers look at to make sure things work well for people. And then the other thing we learn is that volunteer time and energy are the most precious resource that we have, and that anyone who works on sort of this peer review type process or any community code related process. We're relatively proud that we perform reasonably well compared to, say, an academic journal in terms of how long it takes to turn around our packages and articles and how much time reviewers spend looking at it. A lot of reviewers spend a lot of time looking at the source code of a package that they review, and we really appreciate it. But we also know there are limits to what people can do. Pretty much everyone does this outside of their normal work hours, on top of the normal responsibilities. And one really has to be careful not to make too many demands on our users or on the authors, who are going to get a lot of feedback that they're going to have to respond to. And one of the things we try to do to reduce that burden on everybody is do more and more with automation and have a pre-screening process where, much like your CRAN or Bioconductor or our hub, we're able to automate some of the testing of packages. On top of that testing, run linters and other diagnostics so editors can pre-screen things and reduce what authors have to look at. And I'm going to talk a little bit more about new tools that we're developing for that process. So that's peer review as it's run so far at rOpenSci. And now we have a bunch of new initiatives that we're excited about. And the purpose of those initiatives are to make the peer review process more valuable to the authors and the reviewers and the editors that participated, so they can get more out of it. Making it easier so it's faster and simpler, and there are fewer manual processes and fewer hurdles for people to get through. And then, really importantly, expanding the world of people and packages which we can serve. We want to reach out to broader communities and reach into a sort of far larger scope of types of software and types of research support that we're doing. So I'm going to talk a little bit about each of these. One of the neat tools we've set up in the past year, and this is work led by Jeroen Ooms on Twitter, OpenCPU. He's part of our core team at rOpenSci and works on a lot of our infrastructure projects. So what this project is developing and serving, automating building package documentation. So the package down package has been a real boon to a lot of package authors in the past few years to make it easy to develop a website that shows your package documentation and vignettes and other information that one wants to show. And authors on an individual basis can create and deploy those websites. But it does add another step for people to deal with. It's sort of another thing to do in your package development, along with submitting to CRAN or making a hex sticker, getting your package onto a website and deploying it and fixing things and tweaking things is another thing that's sort of added to your list, and we want to reduce that burden. So Jeroen developed our rOpenSci documentation server, which is a tool that automatically builds documentation for many packages. It's built on a Jenkins server. And so anything that goes through the rOpenSci process gets plugged into this. And we serve a website that first of all, gives you all these sort of basics of documentation and a reference and doing your vignettes as package.down would do. Also supports some other things. We make sure to plug in search, to do a bunch of things to help support search engine optimization, to make sure that you get visibility for that. And there's sort of the basics. And of course, you can still customize a website the way you want to. And the tool that Jeroen built is itself open source. So if you run an organization, you can point this to a namespace on GitHub, a whole group of packages, and have this automated development of your package websites and documentation without needing to manage that for individual packages. Another thing that's really important for many of our authors and much of the scientific community is the ability to uncover software citations. It is often hard to get the scientific credit for people who are research software engineers. You know, software doesn't always publish well. Sometimes you can get things in a journal like the Journal of Open Source Software, but it's often not all that often that software is cited explicitly, or if it isn't, it is in the right formal way. So for years, one of our founders, Scott Chamberlain, who's the rOpenSci technical lead, has run a project where he sort of had a curated, partially search-based, partially manually reported database of every time an rOpenSci package has been cited. And that's something we've built into our package pages so that if you go to our package database and you click on a package, you'll see all of the scientific citations of that work. Now, together with James Howison at UT Austin, we're expanding that into a larger, more automated system built on an existing project called CiteAs that uses natural language processing to discover both formal and informal citations of software throughout scientific literature. And that is going to merge with this and the documentation server so that people who go through our peer review process, but then again, anyone who wants to make use of this tool will be able to display, here are all the citations of the software I've developed. And that's something that can be used to support a CV, but also just helps authors see how their work is being used in the world, what type of impact it's having, and that allows you to do a better job in development to target that audience and make better tools to have a bigger impact. There's a whole sort of other view that one can have into the types of uses that people have. So not just in the scientific literature, but lots of times people will write a blog post or a tutorial, or you'll see a Shiny app or an R Markdown thing on the web that uses a tool. And that's something that we like to track, and we like to be able to build a community of users and a body of knowledge around. So anyone who's an rOpenSci author gets a tag on our forum, which is a discussion forum that we use for a lot of different purposes. But one of the things we do is curate use cases of packages. So for instance, the R Natural Earth package, I have an example down here from our forum. You know, we have a tag there for that, and we keep and curate a list of use cases of what people are doing with that package, that they're publishing with that package. And the neat thing about these is they're not just links to places where people have done things, but they're conversations. So people can respond and ask questions about how things are done, you know, can suggest other ways to do the same thing. And that way, authors can use the forum to build the community around their work. So maybe you don't want to use your GitHub issues because that's, you know, where you're sort of managing your bug fix and feature request load. But this can be used to have your users have conversations with each other and provide tutorials and support and conversations around the field that aren't strictly around the code of the package. And Stephanie Butland and Steffi Lazerte, Stephanie's our community manager, and Steffi Lizard is a community member who's been doing a lot with this. They've been curating curating for this for years. So now we have many, many use cases across sort of the whole spectrum of packages. And it's a way you don't have to provide every tutorial and every example. The user community can participate in that. Now, the peer review process itself, we know, can be onerous and take a lot of time. So one project we have going is making it simpler with a chatbot-based automation system. This is something that emerged from the Journal of Open Source Software, and we're extending with the help of Wanzhou Bazan, who helped develop it there. And so the GitHub issue threads where we're having conversations in a review have this bot participating in that now. And we can tell the bot, assign someone as a reviewer, assign someone as an editor, run an automatic check on the package. And all of that can happen in that conversation, which reduces the load of reviewers and authors to, look at their emails and to run things manually themselves. Some of the things that we're hoping that bot will deliver are diagnostics about packages. So not only will the chatbot give you a response to an R command check, but we're developing a series of different diagnostic components that give authors and reviewers benchmarks and guidebooks to software. So one example that we've had a bunch of examples of, and Mark Pajam is working on this part right now, is producing a network of the package dependencies and the internal function network, and then giving you a bunch of benchmarks as to say how many lines per function do you have on average in this package, and how does that compare to the distribution of other packages in rOpenSci or CRAN? How fragmented is this? How organized is this? These are all things that provide guideposts to authors to benchmark themselves and reviewers to understand what they're getting into and how to go through the code by line and understand it. One thing we're really excited about is reaching out to broader communities in a number of ways. Melina Vidoni, who's one of our editorial team, initiated a community call late last year in which we began talking about multilingualism, not in a programming sense, but in a human language sense in our communities, and how we can expand the process to authors who are not primarily English speakers and people who are developing software that may not be for potentially English speakers. We brought along Emilio Bruna. He's the editor-in-chief of Biotropica, which is one of the sort of most multilingual journals out there in terms of author and reader bases, who taught us a lot about best practices. And this is something we're actively aiming for in the next year, which is to do outreach and have sort of non-English package authors and reviewers, be it that a package is written in a non-English language, or simply want the review to occur because that's best for the authors in a non-English language. We've had a lot of interaction and good work with the various communities of practice in Latin America, which La Acción has helped facilitate. And that's something that at a place we're going to start. But so I think certainly we're sort of at the ready to do this for Spanish. But if there's an opportunity to do it in Hindi or Chinese or French, it's something we are eager to try and learn the lessons and turn those lessons out to the broader community. And then by far the biggest project is expanding the scope of the R packages that we review. I've talked to you about how most of our packages are about the data management lifecycle and bringing together sort of that research process with software engineering, but it leaves out a very big part of R that most people go to R for, which is the packages that implement statistical algorithms. Mark Pajam, who I mentioned before, is leading this side of the work. And that's developing a whole new set of standards and processes for reviewing packages that aren't based in, say, our expertise of how metadata should be formed or the best way to hit an API endpoint, but software that's dealing with linear algebra, that's implementing bootstraps appropriately, that's implementing our statistical algorithms and improving the peer review process for that so we can bring new expertise and review those types of packages. Previously, we haven't covered these, because of sort of that data lifecycle focus. We focused on things that pull data or manage data or transform data, do validation or testing, or maybe help connect with lab or field tools. But what Mark did is he went out and looked at every submission that we had received that we had rejected because it was the wrong type, or is submitted to the Journal of Open Source Software or the Journal of Statistical Software, or a number of scientific and statistical software conferences, and sort of built a typology of the types of software that we would want to manage. And they fall out into these categories here. So, things that are statistical visualization, things that are Bayesian, things that are primarily sort of machine learning, supervised or unsupervised. And what we're doing is developing targeted guidelines for these different categories of statistical software, because one size is not going to be fit all for all of these. This is an opportunity to go back and reinvent a lot of what we're doing. And it's something we want to do collaboratively and intercompatibly with a lot of other groups, because we want to develop review standards and performance standards that other groups can use, and can use modularly, so they can pick up something, we like what this is saying about data structures for time series, and we're going to adopt that and make that a point of review or requirement for our journal or our collection of packages or our approach for our members, but other things can be left aside. And so we're trying to draw as much as we can from conversations from a lot of different groups. Many of you will be familiar with some of them up here. The R Validation Hub is a really interesting project out of the pharmaceutical industry, which is really focused on risk related to software failure in pharmaceutical trials, and have a very sort of specific set of approaches to risk, which is something we can draw from. And then another group that's of interest, say, is the STAN development team, who are seeing their software being used as a component of a lot of other work and has best practices about how that should be done. So we're trying to draw from all these groups and work back with them in order to get sort of a set of packages that are really useful. This also requires a bunch of new expertise. So we have an existing editorial team that's on the left. Brooke Anderson's our current editor-in-chief, and these are the people who've had a lot of experience sort of managing that peer review process. But we decided to bring in sort of a whole new editorial and advisory board, which are the people on the right, which have much more of straight statistical background than sort of the research software engineering that has become the focus of a lot of core rOpenSci. And they're just the tip of the iceberg, because we've had so many great inputs from so many other community members. And that's something that we want to drive. And I'm hoping that many of you who are listening will want to come on board and give us your thoughts and opinions and advice about what you want to see in standards for peer review of statistical packages. So there's different things that we want to get at within these standards. There's the what, what do we want to have as standards? What benchmarks do we want? What common agreed practices do we want? And then how do we want to go about the process of doing that? This is an opportunity for us to reinvent. So we're looking at standards about how one looks at algorithm correctness. It's a very high bar. What's sort of the minimum process we can use and the minimum requirement we want for people to show that? What are the things that we think statistical packages should all document? We think, we're thinking along the lines of making it clear what the assumptions and the limitations of the method are, pointing to the right places where you can get more information, understanding the type of data that things have been tested on, and what is sort of outside of scope of what works. There's a lot of thoughts about standardization of APIs. Are you using R's formula interface properly? Is it clear what's going behind the scenes with model matrix creation and things like that? And are authors making robust architectural decisions and dependency choices that enable things to be maintained in the long term and be compatible with other packages? And then testing completeness, not just in terms of code coverage, but of the types of things that might be thrown at a statistical modeling function, is something we're thinking a lot about. And then drawing from all of those different groups, we're actually thinking about, jiggering our model of what we think of as peer reviewed or accepted. So there's sort of the accept or reject model, but the Linux Core Infrastructure Initiative has sort of a self-certification where people can show that they've hit all of these things. And we want to be able to at least let authors, be able to run the tests and sort of be able to check all the boxes themselves first. And probably in terms of pushing the community to adopt better practices, something that's not binary may not be the right way. Maybe there's a set of minimum standards and then best approaches and top of field approaches to testing and robustness that'll, you'll get a certification, with a star if you're able to do all of these things. This will require a whole sort of new approach to reviewer training, which is something that we'll be doing because it's new expertise we need to give people. And then just like everything else, we want to build tools so that you don't have to write a test for every type of data your package might have. You can write one test and we can automate the throwing the different types of data, the same data bootstrap, the same data filled with NAs, the same data, but replacing a variable with something that's perfectly collinear so that you can see what all of your package performance is like under those conditions, rather than trying to come up with every one oneself. That testing is really something that is what we're diving into a lot now. And we've gotten a lot of great input from Alex Hayes, who isn't formally part of this project, but has written a lot about it. And if you're interested in this, I'd really recommend going and looking at a couple of blog posts of his that he's written about statistical software architecture and testing statistical software. We're drawing a lot from this and then building upon it in other ways. And, helping authors think through, how do we test correctness? How do we test that an algorithm is giving us the parameters we expect? What's a good measure of convergence that you can use in your package to test convergence? And how do you deal with not just permutations of data that might segfault the computer, but could have subtle effects on the outcome of a statistical test, not just in sort of an exact way, but in sort of a statistically robust way. This is a big project that's going to require input from a lot of people. And it's something we want you to participate in. We have a whole section in our forum for people to dive into. Mark has developed a lot of research that we have background for, things like what Alex has written, but things drawn from different software engineering literature, statistical literature. We've spoken to people who have done some of the validation work in sort of the private statistical industry. So the best place to dive into that is the rOpenSci forum. You join up on the forum, you're a member. You comment on the thread, that's how you become part of the working group. I swear we will certainly practice commitment escalation to bring you on board to do more. Because in the end, these standards are community standards that we want people to agree on, and we want people to be happy following, and that we want to be a tool so that people not just going through our peer review process, but just doing other things where they want to have good resources to determine for themselves that their own code is trustworthy, that something else they're looking at is something that they can put some faith in. We want them to be widely usable, if not, completely adopted by lots of people. So please come aboard and help us and comment and help us think through this process. We're really looking forward to that. That's all from me. I'd just like to thank again the organizers, the sponsors of the conference, especially our studio, the foundations that have supported rOpenSci through various bits of the projects that I've discussed, and all of you for listening. I'm looking forward to hearing all of your questions. Please go to any of these places to come aboard rOpenSci. There are lots of ways to become a community member and to participate. We think it's a great place to work and a great group of people to help support you in the type of work that you might be doing. So thank you very much.
Thank you, Noam. We have a lot of interest in the questions, actually. There's a lot of people excited about joining rOpenSci. The first question, though, is related to the peer review process. It says, within academia, there is a perception that the peer review process is broken. Hard to find reviewers, large burden on a few folks, low quality reviews. The question is, does rOpenSci face those same challenges? And if so, how do you overcome them?
That's a great question. Thank you. You know, there's definitely more than a grain of truth to a lot of that. There's a lot in peer review that needs to be improved. Generally, there are a lot of those challenges that you see, the burden on a few folks on the quality review, are things that we struggle with, but we really do aim to improve in a lot of ways, and it's sort of baked into design. Part of it has to do with what type of platform we are. We really aim not to be gatekeepers. rOpenSci is not a journal, so you can release your package without going through this. And so we don't want to be a barrier to people, you know, that they aren't getting, if they don't have the stamp, that doesn't prevent them from doing other things. I think that relieves some of the pressure. You know, we are not a hosting repository primarily. We have that capability, but being on rOpenSci doesn't, you know, prevent or allow you to be on CRAN or Bioconductor, right? So by separating from that, that reduces a degree of pressure. And then a lot of it is really about, you know, setting expectations and good communication. So most journals that I see don't have a lot of guidance for authors and reviewers. They have some, right? But not really how to deal with a lot of specific cases. That book that Mael manages is an ongoing living document that people can contribute to. And we really try to use to get specific information to people so people can understand, you know, what's expected of them. They can see example reviews, things that work well, things that don't well. That helps people a lot. You know, and then we really do our best to do that management. I mean, volunteer time is a big deal for everyone. You know, we have a rule, we never go back to the same person more than twice a year. You know, we do ask people to report the amount of time they spend. You know, when people are like, I spent 15 hours looking at that package, we're like, that's great, but that's not what we want, right? If what we need requires that, we need to rethink about how we do things. And that's why we think about automation and focus and sort of spreading the work. So it's a constant challenge, but we do the best we can.
Thank you. Hopefully some journals can get inspired by your guidance. The next question is, how do you become an rOpenSci reviewer?
rOpenSci.org/onboarding. We have a form. You'll be asked to fill out, you know, some contact information, send us some links to some projects that you've worked on so we can get an idea of your expertise, check up some boxes of what are your areas of expertise or other languages. Can you review an R Java package or an RCPP package or something that has HTML widgets? And you'll go in, and then when things are submitted, authors go through that list. And what we try to do is match a person who's done a few reviews with someone who has not done any reviews, that we find that's helpful in order to, you know, you can see the other review, so you can get a sense of what's going on. You can also check a box to ask if you want sort of mentorship through the process as well. So if you're a first-time reviewer and you want an editor to look at your review first, or you want to be able to ask questions, you can always do that. But if you can check that box, we can know that that's something that we can expect.
Great. And I guess that kind of like, yeah, the next question is there a way for graduate students who are relatively new to R to get involved with, or even just observe the peer review of code at our rOpenSci?
Yeah, certainly. So you can, first of all, do sign up as a reviewer. Again, sort of, you know, we match people, and if you're new, we'll connect. But if you go and there'll be a link in the repository. There's a link in my last slide to github.com/rOpenSci software review. You will see the repository. There's all of the issues. And all of the review threads. You can look at all of the threads. You can look at all of the packages, all the conversations that people are having. Also, relatively soon, we know we have a lot of different points of entry to the rOpenSci system. As a reviewer, as an author, or other community members, we have meetups and community calls, like that one that we used to start our multilingual work, which are ways to participate. We're going to be putting out some new documentation in the next few months, which is going to be our community contributing guide. So there's just lots of points of entry, because people don't just do review, but can help out in the issues on the ongoing maintenance of all those packages. We've seen that happen, and then that evolve into sort of maintenance being transferred. Someone maintains something for a few years, realize they can't, but as value to the community. So someone who's been helping out is able to come on board. And jump in the forums and start giving feedback. As soon as we have our hooks in you a little bit, we'll be asking you what else you want to do.
Okay, great. One more question. Are you considering expanding the scope beyond packages to include peer review of analysis scripts before going to journal peer review?
Yeah, so this is a great question, and it's something we've thought of a lot and don't have currently a structured project around, but is a thing that we have sort of tried a bunch of things in the past and would be eager for people to come on board and help us think through it, and if they want to take something on. So for instance, we have a couple of things that have been written that probably are not sufficiently visible that came out of some of the conferences that we've had in previous years that are sort of a series of checklists for reviewing a research compendium as opposed to just a package. We do have a number of papers, and I'll add links to those, and guidance around building a research compendium, or sort of a reproducible research artifact to accompany a paper, and the best practices for that. Within the R world, we've written about that, and then we have, that can be something that's a basis for review. But it is a really challenging thing, because the nice thing about the package environment, there's a agreed upon structure to start with. And so a lot of what we've written, a lot of what we tried is about sort of figuring out what that initial agreed upon structure can be, because without that, it is really difficult for the reviewers to be able to sort of pick up the hooks, right? A package, we can define what the dependencies are. I can tell you a dozen different ways to define the dependencies so your reviewers can run your code. But I can tell you no one that has agreed on how that should work. So it is a challenge. It is a thing I think we want to do more of. Please come on board and help us do it, because we haven't figured out where to get our hooks into it yet.
Next question. Are you considering expanding? Oh, sorry. Do you have any examples of how a review has really changed or improved a package?
Oh man, many. I think it's the case. Most reviews are not looks great, goes on, which is not the case anywhere. But I think the feedback always really does work, and it's. Every package I think of has some of this. I'll just pick Artica is a thing that wraps a text harvesting tool that's from Java. We had one review that was really great about a better way that makes it easier for users to install the Java dependencies, and made it really straightforward and made it easy to install. And that was the main focus of one reviewer. And the other reviewer was like, your vignette gives some good examples of how one analyzes this text data, but you're actually only using one of your functions and then going on and sort of repeating an analysis that you've shown elsewhere that uses a bunch of other packages. Can you walk through the different capabilities of your function? So your vignette sort of gives the story of your package in addition to sort of how to do a text analysis. That's one of many. Maybe a lot of times, here's a much better set of names for your functions that make it clearer to work. We can remove 3 dependencies and 5 minutes of install time because you're only using one function that actually exists in another package. There's so many stories of this, and so in our development guide, we have examples of some of the best reviews, and feedback is in the reviewer guide. Here are great reviews and great responses. But I'd say that's the case across the board.
Okay. I guess we have time for one more question. How do we get authors to cite the software they use, just like they cite a paper as context? Could journal authors, guidance, or professional associations be the key in this case?
I think they definitely are. It is definitely a two-way street, because it's not easy necessarily for authors to cite software, because software the journals may not have, it doesn't have the template for that right type of citation. And so I think having that guidance and having that sort of requirements at journals and associations is good. And then the things we have to do is make sure the software is citable. Does it have the archival link to it? You know, does it have its DOI? Do we have the citation file in the package? One of our leadership, Carl Bettiger, has worked on a project called Code Meta, which is a standard citation and metadata format to put in a repository. And that makes it really easy for services like Crossref to discover software and bring it into the citation ecosystem. And so it's going to require a push on all fronts. It's something that I do ask, you know, reviewers, and when I'm a manuscript reviewer and an editor, I'll be like, you know, it seems that there's an important piece of software that you're not, here's the citation for it, you just mentioned it. And so it is something that, you know, is practice across the board that has to be improved.
Well, thank you so much, Noam. Our time is up, but thank you so much for your talk and for all that great guidance that you're creating with the team at rOpenSci. And thanks to the audience for joining us and for watching us later, maybe. Please check out our schedule for more great content. Thank you.
All right. Thank you very much.